Hello guys, welcome to Makaut Smashers and also welcome to our video on blockchain technology. Today we will dive into the fascinating world of blockchain, exploring what is and why it's revolutionizing the industries worldwide. From understanding the basic components and the types of blockchains to exploring their key features and real-world applications, we will cover it all. You will learn about the mechanisms that ensure secure transactions and potential challenges facing this technology. We will also take a look at the future of blockchain and its transformative potential. So let's get started and unravel the mysteries of blockchain technology together. Okay. So now it is time to discuss about the fundamentals of blockchain technology. Blockchain technology initially designed to support the Bitcoin, which is a decentralized digital ledger that records the transactions across the multiple computers in a way that ensures the security, the transparency, and the immutability of the data. Each transaction is grouped into a block, and these blocks are linked together chronologically in a chain using cryptographic hashes. This structure prevents the tampering, as altering any block would require changes to all the subsequent blocks, which is computationally infeasible. Okay, so the key features of blockchain is its distributed nature. Instead of relying on a central authority, a blockchain network is maintained by a network of nodes, each holding a copy of the entire blockchain. These nodes validate the records, record the new transactions through a consensus mechanism such as a proof of work (POW) or proof of stake (POS). POW involves solving the complex mathematical puzzles, while POS selects the validators based on the number of coins they hold and are willing to stake as collateral. So blockchain's public transparency it's come from its public ledger, which allows anyone to view the transaction histories. This feature is particularly valuable in sectors requiring the accountability such as finance, supply chain management, and voting systems. Additionally, blockchain security is enhanced by its use of cryptographic techniques and the decentralized nature of its network, which reduce the risk of single point of failure and attacks. So smart contracts are another innovation enabled by the blockchain. These are the self-executing contracts with the terms of the agreement directly written into the code. Then they automatically execute and enforce the contractual conditions when predetermined conditions are met, reducing the need for intermediaries and increasing the transactions efficiency. Blockchain technology also supports the development of the decentralized application, which run on a peer-to-peer network rather than centralized servers. These applications can operate with greater resilience and censorship resistance, fostering the innovation in areas like finance, healthcare, and beyond. So, despite its advantages, blockchain faces challenges such as scalability, energy consumption, and regulatory uncertainty. However, ongoing research and development aim to address these issues with solutions like sharing and more energy efficient consensus mechanisms being explored. Overall, the blockchain technology represents a transformative approach to data management and transaction processing, offering robust security, transparency, and efficiency. So, its potential applications extend far beyond cryptocurrencies, promising to revolutionize the various industries by enabling the new forms of digital trust and collaboration. Okay. So now it is time to discuss about the types of blockchains. So now blockchain technology and types of blockchains. Blockchain technology comes in several forms, each suited to different use cases and requirements. The primary types of blockchains are public, private, consortium, and hybrid blockchains. Public blockchains like Bitcoin and Ethereum are open to anyone and operate in decentralized manner, allowing any participants to join and validate the transactions. They offer the high transparency and security, but may face the scalability issues and slower transaction speeds due to their consensus mechanisms such as proof of work POW. Okay, so private blockchain on the other hand are restricted to a specific group of participants and are typically used by organizations for internal purposes. These blockchain offer the faster transaction speeds and greater control over the data access and governance, but sacrifice the level of decentralization and transparency found in public blockchains. They are suitable for use cases requiring confidentiality and efficiency, such as supply chain management and enterprise resource planning. Consortium blockchain, also known as federated blockchains, are a hybrid of public and private blockchains. They are managed by a group of organizations rather than a single entity, combining the benefits of decentralization with the controlled access. This type of blockchain is ideal for industries where multiple entities needs to collaborate and share the data, such as banking and healthcare. So, consortium blockchains enhance the trust and the transparency among the participants while maintaining the privacy and efficiency. Hybrid blockchain. This aim to combine the advantages of both the public and private blockchains. They allow for selective transparency and access control, enabling the organizations to keep the sensitive information private while making other data publicly accessible. This flexibility makes the hybrid blockchains suitable for use cases like real estate, where the public records of ownership can coexist with the private transaction details. So each type of blockchain has its strength and weakness, and the choice of which to use depends on the specific needs of the application. Public blockchain offer the highest level of decentralization and trust. Private blockchains provide control and speed. Consortium blockchains facilitate collaborative environments, and hybrid blockchain offer a balance of transparency and privacy. As blockchain technology continues to evolve, these different types will likely to play complementary roles in various sectors, driving the innovations and efficiency across the industries. So now this is time to discuss about the key features of blockchain. At first, blockchain technology is characterized by several key features that distinguish it from traditional data management systems. At its core, blockchain is a decentralized ledger that operates across a network of computers, ensuring no single point of control or failure. This decentralization enhances the security and reduces the risk of tampering, as altering any part of the blockchain requires consensus from the majority of the network participants. So transparency is another hallmark of blockchain. Every transaction recorded on a public blockchain is visible to all participants, fostering the accountability and trust. This transparency is achieved without the compromising the privacy, as transactions are pseudonymous, identified by cryptographic address rather than the personal information. Immutability. It is crucial feature of blockchain. Once a transaction is recorded in a block added to a chain, it cannot be altered or deleted. This immutability is ensured through the cryptographic hashing, which links each block to the previous one, creating a secure chain that is resistant to tampering and fraud. Consensus mechanisms such as proof of work and proof of stake are integral to blockchain's operation. These mechanisms ensure that all participants in the network agree on the validity of transactions before they are added to the ledger. So, proof of work involves solving the complex mathematical problems, while proof of stake relies on participants staking their assets to validate the transactions, both providing the security and trust in the network. Smart contracts are self-executing contracts with the terms of agreement directly written into code. These contracts automatically executes when predefined conditions are met, reducing the need for intermediaries and enhancing the transaction efficiency and reliability. Security in blockchain is bolstered by advanced cryptographic techniques. Each transaction is encrypted and linked to the previous one, ensuring the data integrity and protection against the unauthorized access and cyber attacks. Decentralized applications or DApps run on blockchain networks and benefit from its inherent features of transparency, security, and immutability. These applications are not controlled by a single entity, providing the resilience and reducing the risk of censorship. Tokenization is another feature where the real world assets or rights are represented as digital tokens on the blockchain. This allows for easier transfer and ownership, tracking, and division of assets, opening up new possibilities in various sectors including the finance, real estate, and supply chain management. Interoperability enables different blockchain systems to communicate and share the information seamlessly, enhancing the usability and adoption of blockchain technology across the different platforms and industries. Scalability remains a challenge but is being addressed through the innovation like sharing layer 2 solution, which aim to increase the transaction speed and the network capacity without compromising the security. So these key features make the blockchain a transformative technology with the potential to revolutionize the various industries by providing a secure, transparent, and efficient ways to manage and transfer the data. So now it is time to discuss about the blockchain consensus mechanisms. Blockchain consensus mechanisms are fundamental to ensuring the validity and the security of transaction in a decentralized network. These mechanisms enable the network participants or nodes to agree on the state of blockchain, ensuring that all copies of the distributed ledger are identical and up to date. The most common consensus mechanisms include proof of work, proof of stake, delegated proof of stake, and practical Byzantine fault tolerance. Proof of work (POW) is a consensus mechanism used by Bitcoin and involves solving the complex mathematical puzzles. Miners compete to solve these puzzles, and first to do so gets the right to add a new block to the blockchain and receive a reward. Proof of work provides the high security but is energy intensive and can lead to slower transaction times as network difficulty increases. Proof of stake addresses some of POW's limitations by selecting the validators based on the number of coins they hold and are willing to stake as collateral. Validators are chosen randomly to propose new blocks, and their chance of being selected increases with the amount of their stake. POS is more energy efficient and can process transactions faster than POW, but it may face issues with the centralization if a few participants hold a large portion of the tokens. Delegated proof of stake is a variant of POS where the stakeholders vote for a small number of delegates who are responsible for validating the transactions and maintaining the blockchain. This system can achieve a higher scalability and faster the transaction speeds, as only a limited number of nodes are involved in a consensus process. However, it can also lead to a centralization risk if a small group of delegates gains too much control. Practical Byzantine fault tolerance is designed for permissions blockchain networks where the participants are known and trusted. In PBFT, the nodes communicate with each other to agree on the order and validity of transactions. These mechanisms can achieve consensus quickly and with lower energy consumption, making it suitable for enterprise applications. However, it requires a significant amount of communication between nodes, which can limit its scalability in larger networks. So others like proof of burn, proof of capacity. So energy consensus or each consensus mechanisms has its strength and trade-offs, and the choice depends on the specific requirements of the blockchain network such as security, scalability, energy efficiency, and decentralization. As blockchain technology evolves, the new consensus mechanisms continues to be developed, aiming to improve the performance and the applicability of decentralized systems. So now it is time to discuss about the application of blockchain. Blockchain technology has a wide range of applications across various industries due to its attributes of decentralization, transparency, and security. In finance, blockchain enables the secure and transparent transaction, reducing the need for intermediaries and lowering the cost. Supply chain management benefits from blockchain by providing the traceability and accountability, ensuring the product authenticity and reducing the fraud. Healthcare uses the blockchain for secure patient data sharing and management, enhancing the privacy and interoperability. Blockchain is also applied in voting systems to ensure the transparent, tamper-proof electoral processes. Additionally, blockchain supports the creation and management of digital identities, protecting the personal information and reducing the identity theft. In real estate, blockchain simplifies the property transactions by providing the clear ownership records and reducing the paperwork. The technology also powers centralized application and smart contracts, automating and securing the agreements across the various sectors. Okay. So thank you for joining us on this journey through the blockchain technology. We have explored its fundamental key features and the diverse application, shedding light on both